I had some luck. All the big shots, by some kind of accident, everybody but Hans Baker happened to have left at the same time. Like Weisskopf had to go back to fix something at MIT, and Teller was away just at a certain moment. And what Beta needed is somebody to talk to push his ideas against. So he came into this little squirt in an office, and he starts to explain this idea. And I says, no, you're crazy. It'll go like this. And he says, just a moment. Then he explains that he's not crazy, that I'm crazy. And we keep on going like that. But it turned out that although, you see, when I hear about physics, I just think about physics, and I don't know who I'm talking to. So I say the dopiest things like, no, that's wrong, or you're crazy. But it turned out that's exactly what he needed. And he was, so I got a notch up on account of that. And so when I ended up as a group leader with 4 guys under me, which is underneath Beta. There was several groups, but I wasn't quite as far below as the title might indicate, but I wasn't anywhere up anywhere. I had a lot of interesting experiences with Beta. The first day when he came in, we had an adding machine at Marchand that you work with your hands. And so he says, let's see. He said, the formula they've been working out, he says, involves a pressure squared. The pressure's 48. The square of 48. I reach for the machine. He says, it's about 2,300. So I plug it out just to find out. He says, you want to know exactly? It's 2304. And so it came out 2304. I said, how do you do that? He says, don't you know how to take squares and numbers near 50? If it's near 50, if it's, say, 3 below, then it's 3 below 25, like 47 squared is 22. And how much is left over is the square of what's residual. For instance, you're 3 lost, so you get 9, 2209 for 47 squared. Very nice. Okay. So we keep on, he was very good in arithmetic. So we kept on going, and a few moments later, we had to take the cube root of 2.5. Now, to do cube roots, there was a little chart that you take, and you have some trial numbers that you try on the adding machine the Marchand company had given. So I open, this takes them a little longer, you see. I open the drawer, I take out the chart, he says 1.35. So I figured there's some way to take cube roots numbers near 2.5, but it turns out no. How do you do that? He says, well, he says, you see, the logarithm of 2.5 is so-and-so. You divide by 3 to get the cube root of so-and-so. Now, the log of 1.3 is this, the log of 1.4 is this. I interpolate in between. I couldn't have divided anything by 3, much less. So he knew all his arithmetic, and he was very good at it, and that was a challenge to me. I kept practicing. We used to have little contests. Every time we'd have to calculate anything, we'd rush to the answer, he and I would win. After several years, I began to be able to do it, get in there once, maybe 1 out of 4. Because you'd notice something funny about a number, like if you have to multiply 174 by 140, for example, you notice that's like 173 by 141, which is like the square root of 3 times the square root of 2, which is the square root of 6, which is 245. But you have to notice the numbers, you see, and each guy would notice a different way around. We had lots of fun.